Okay, welcome to today's video, day 6, application system word problems solving graphically. So now we're going to look at, instead of solving algebraically, solving by graphing. So the first question here says, next weekend, Maggie wants to rent a car. Enterprise charges $2.50 per mile with a down payment of $60. And then we have a different situation. Hertz is a different company. They charge $1 per mile, and they have unlimited miles. No fee, nothing like that. No down payment that I can see, nothing equivalent to that. So what we need to do first, since this is a system, we need to write, and they're telling us two functions using E of x for the enterprise and H of x for our Hertz to model the situation described above, with x representing the number of miles driven. So in that statement, they're telling us what the x is. That's our let statement. X represents the number of miles driven. So I'm going to first start with enterprise. They have charged 25 cents per mile and a down payment of $60. So I have my equation, E of x equals, and then the 0.25, 25 cents per mile, x times the miles, plus the $60 flat down payment fee. So this is my equation for enterprise. Now I need to make one for Hertz. Hertz charges $1 per mile, unlimited miles, so there's no fee, no down payment, nothing like that. So this is just going to be the h of x equals 1x. Okay, now I have my two equations written, and I can move to using the grid to sketch each function. So all I did so far is bring down my equations so that I can still see what they are. I'm going to use the grid to graph them. Now you can use slope and the y-intercept if you'd like to. So the slope would be 0.25 or 1/4. And the y-intercept would be 60, but you have to also look at the scale to make sure that you're going by the right number. So what I'm going to do is I'm going to go ahead and get a table of values. This one would have worked out pretty well because it's counting by fives, but if they had something like counting by twos or something like that, it might be harder to use. So I'm going to go to y equals in my calculator. I'm going to sub in the 0.25x plus 60. Then we're going to go to second graph to look at the table of values. So now when I look at the points, I can see nice points. I don't want to do the decimals, but I can see some nice points. But I also notice that when I look at my scale here, the number of miles driven is going up by fives for each line. So I don't really want to do in between 0 and 5 because that's not really a good point that I can go and graph. So I'm going to look for at least like 5s or 10s. So we can change if you want to. You can change your table setting. You don't have to. We'll go over this more in class, but you can do second window to switch your table to start at whichever value you want, probably 0 because we can't go into the negatives. And then you should have if you go down, there's the triangle, delta, the change in the x values, and you can change that to be whatever you want it to be so that we can count by, in this case, 5. So I'm going to change that to a 5, so then my table adjusts to the scale that I have here. Now, if you didn't want to do all those table setting changes, you can just keep moving down and look at the number 5 and then scroll down until you get to a 10. It'll just be more of pressing the down button to skip those in-betweens. Either way is absolutely fine. So with changing it to counting by 5s, the next good point after 0, 60 that I see is 20 at 65. And then I have some more decimals, and then I move down to 40 is at 70, and then 60 is at 75, and 80 is at 80. Now I see I went up to 100, so I could keep looking down to see what 100 is if I want to, and I would see that 100 is at 85. That'll fill my whole graph in, and then I can go ahead and plot those points. So once you have those points listed, you just need to go over and graph them on your grid. So 0 is up to 60, then I need to go over to a 20 up to 65, and then 40 was at 70, and 60 up to 75, 80 up to 80. And then 100 is at 85. Okay, so now that I have my points, and once I've connected with a nice straight line, I need to put a label on here, at least the e of x, so that I know which equation I just graphed. You can put the whole thing on there if you'd like. And then remember, I only have an arrow on one side, and that's because this is continuous. It can continue to go up, but we can't go into a negative number of miles or a negative cost, so it needs to stop at that 0 for the number of miles driven. Okay, now we'll graph the h of x. So by doing the same thing, I'm going to go to my table and I'm going to plug in y equals, I'm going to put 1x, and then I'm going to go back to my table. Mine I adjusted like I had said, so I'm going to leave it adjusted so that I see 0, 0, and then the next point that I see on mine is 5, 5. So I can start writing down these nice points. These are ones that I can graph. 10 was with 10, 15, 15, 20, 20, and so on. I could stop there and just plot those points. I usually like to see what happens at the last one. So at the x value of 100, my y value is also 100. So that'll help me just to see where the graph goes at the end and connect a nice straight line. But it's up to you. Once you have the first few points, once you have 5 points and you can use your straight edge to connect them, that's fine also. So 0, 0 is the first dot, 5, 5, 10, 10, 15, 15, 20, 20, and then like I said, the 100 is up at 100, and I just did that so I could see, well, where does this graph end up at the end here? Then I can use my straight tool, straight edge, to go ahead and connect those points. Make sure that you use a straight edge so that you can actually have all the points that are on there on your graph, and you don't make mistakes, and then that'll help you to answer the follow-up questions. And once you have your nice straight line, remember that you need to label that also. Now, I was able to use e of x and h of x since those were different. Those could be used as labels. If they were both y equals, I couldn't just write y equals and y on each one. I wouldn't be able to decipher which one is which. So the reason I could just write the e of x and the h of x is because they were in function notation. Okay, let's try some follow-up questions. Okay, the first question here says, which company should Maggie choose, and justify your reasoning? Well, they're not giving me a specific number of miles or anything that Maggie is going to drive, so I'm going to say that the cost depends on the number of miles. So if she's driving anywhere that's less than this point where they intersect here, any of these values, it would be better to use my red function, my h of x, because the cost is cheaper. But once you hit 80, they would be the same. I can see that from the intersection here. And once it goes above 80 miles, well, then the enterprise is actually cheaper. So it depends on how many miles she's going to drive. Okay, so I just worded that out as which company Maggie uses depends on the number of miles driven. Hertz is best if she is traveling less than 80 miles, but Enterprise is best if she is traveling more than 80 miles. At 80 miles, she can use either company as the cost is the same, and I can see that on the graph and also on my tables. Since I used my tables, I can go to an x value of 80 just to make sure that the cost is 80 for each of those, and it is. I could also check by putting them in the calculator and tracing the intersection like we've done in class. The next question says, determine the number of miles Maggie can drive such that the total cost of renting a car is the same. Well, I already answered this question in the previous, but that would be the 80 miles that I talked about previously, the point where they intersect, because then it's the same cost of $80. Okay, my next question here says that Janelle and Stacy are taking a 50-question true or false test in their history class. Janelle starts after Stacy already finished 12 questions. So it's a 50-question true or false test. Janelle starts after Stacy already had 12 questions done. Janelle answers questions at a rate of 2 per minute, and then we have Stacy who answers them at a rate of 5 questions every 4 minutes. Janelle eventually catches up to Stacy. We want to write a system of equations that models the situation. Well, we have that it started off with the 50 questions, and we have them answering them at different rates. So, what is the unknown? The unknown is how long it'll take for them to catch up. We know that eventually they'll catch up, that Janelle will eventually catch up to Stacy, but we don't know when. So, X is going to be our number of minutes. So, if you want to write down a let statement first, so I started out by writing let X equal the number of minutes, and then Y is the number of questions that they've answered. So now I'm ready to go ahead and write my equations. And actually, as I look at the graph, I can see that they, on the x-axis, they have an M there. So I'm going to put the M in for the number of minutes. And again, that's just because I can see that in my answers down there. I could change it to J of M and S of M if I wanted to, but I'm just going to leave it as Y equals, but I'm using M instead of the X because that's what's shown on the graph. Okay, so my first person I have is Janelle. She answers the questions at a rate of 2 per minute. So Janelle's equation is just 2M, 2 per minute. And then I have Stacy. Now Stacy had started before Janelle, so when Janelle is at 0 where she had started, Stacy has already answered 12 of the questions. So that means that the y-intercept is 12 for Stacy at the beginning of this time that has passed. And she answers the questions at a rate of 5 questions every 4 minutes. So that's 5 questions per 4 minutes. That's the slope, 5 over 4. Remember, that's like a rise over run, so that's how I knew that it was 5 over 4. 5 questions every 4 minutes, and that's my x, the minutes. Okay, so now that I have my 2 equations, I'm ready to go graph them. Now, we can use the slope and the y-intercept, but I think that this equation, Stacy's, makes it a little harder because if I started at the y-intercept of 12, that's 10, and then 12 is right here because they're counting by 2's. So this is 12. Now, rising 5 is not going to be up 5 blocks because each one is worth 2. So I'd have to go up 2 and then a half to go up 5, and then I have to go right 4, which is actually 4 spaces, 1, 2, 3, 4. So that would be my next point, but that's kind of hard to do. So I think this is a better use of using y equals and looking at the table of values. Remember that we have to put an x instead of an m since we just put x's for our unknowns in our graphing calculators. So let's start by graphing Janelle's. We're going to go to y equals. We're going to plug in the 2x. Then you're going to go to second graph to look at the table. But if we look right away, if you changed it like I recommended in the last one, first we need to go back by hitting second window right next to the y equals button for the table set. And we need to change that delta table to change to count by ones again, because that's going to be a better use of the graph here since the x's are going up by ones. And then we're going to start at 0 again since we can't start with have any negative in this real life situation. Okay, so once I've readjusted my table, then I can write down the table that I see in my calculator. Okay, so when I looked at my table, I wrote the x and the y values down. Now technically the x is standing for m here, but I just had the x because we had put it in the equation, and when I look at the table, that gives me the x. Either way is really okay. And then I wrote 0, 0, 1, 2, 2, 4, 3, 6, 4, 8, 5, 10. Then I jumped to 20, and that was because I saw on my x-axis that the furthest x value I had was 20, so I wanted to see where that y value would be. Okay, and then now that I have those points written down, I can go ahead and graph them on my grid. So remember to look at your x and the y scale when you do that to make sure that you're using the correct scale. And then once I've plotted all my points, I can connect them with my straight edge, make sure that you're using a nice straight edge so that you can have a line that goes through all the points. And then once you've done that, remember that you can put your arrow going up because it said that it was a 50 question quiz, so we're not quite done yet. It's not like they stopped at the 50. So I can keep going this way until I've reached the end of the question, the end of the quiz, so I can put an arrow here, but I can't put an arrow on the other direction, and that's because, and actually my line even went a little bit past, I'm going to change that. I don't want to go past this point at all because I can't go into my negatives. I need to show that I can't have negative time. I can't have the negative number of questions. So this needs to start at the 0, 0, and then I can go up forever. And I used y equals for my equation, so I need to make sure that I put the whole label on my equation. So y equals 2m. Now I'm ready to go ahead and look at Stacy's graph. So I'm going to go back to y equals, and then I'm going to put in the 5/4. Remember that we need to put the x instead of an m, plus 12. That's going in y equals. We adjust our table back, so that's fine. And then I'm going to write the values down from my table. Remember, you get to that by hitting second graph to go to your table of values. So when I look at my table, the first point I see is 0 is at 12, and that was my y-intercept. And then I'm going to look for some nice points that I can graph. So I see 4 is at 17. And then when I keep looking, I have 8 is at 22. And then 12 is at 27. 16 is at 32. 20 is at 37. And then, like I said, I like to get an idea, and that's 20, 37. That's the last x value that I can plot. So now I have the points that I can show on the graph that they gave me. So now I can go ahead over and plot all those points. Okay, so you can see I plotted all those points, and then I connected them with a nice straight edge. I can see the solution on my graph. I can also check it on the table, or tracing the intersection. Now I didn't show 16 on my other table, but I can see from the graph that it looks like 16 is the intersection. If I have both of them in y equals, I can double check that by looking at the table or using second trace to calculate the intersection. And I'm going to throw a label on my other one. I'm going to label it down here just so that it doesn't get into the other equation, 5/4 m plus 12. Okay, now let's go answer some follow-up questions. Okay, the one follow-up question for this one is how many minutes does it take her and what question are they on when Janelle catches up to Stacy? So we already kind of talked about this point. When they catch up, those words mean that when she catches up, that means that they're equal to each other. So that means that they're going to be on the same question. When does that happen? When we talked about it, it's on the graph. It's that intersection. So my solution is this point here. So what does that mean? After 16 minutes, they will catch up on question 32. So that's by following 16 is on the x-axis, so that's 16 minutes, and then over here they're counting by 2, so that's question 32. So my answer is Janelle will catch up to Stacy at 16 minutes on question 32. Okay, that's it for this video. I will see you tomorrow. Have a great day.